Welcome back, guys. This will be a rather short lesson. So all we will do is calculate our levered IRR. So basically our internal rate of return in our levered case. Levered meaning that we will assume debt financing or gearing. And what we will do first here is give this a heading. So let's write return metrics, alt HJ, that's a header 1 style. Our first return metrics will be our internal rate of return, or short IRR. Hit enter, alt HJ, that's a header 2 style. And the internal rate of return is by far the most commonly used return metrics when it comes to renewable energy investments. So this will be the main figure that any investor or project developer will want to look at first when determining how good this investment really is. And before we calculate our IRR, a brief explanation what this return metrics basically says. So the IRR assumes that all future cash flows will be discounted at an internal rate of return, so that all future cash flows discounted at this rate will equal our total equity investment. So the present value of all our future cash flows discounted at our IRR will equal our equity investment. The IRR is basically the return which will make our net present value equal 0. And what this means is that early cash flows in our early years will be discounted for a shorter period than our cash flows in our late years. So basically, if we discount those cash flows in our last years at a very high rate on a per annum basis, then they will not contribute a lot on a net present value basis to our equity investment. So the more cash flows we receive in early years, the higher our NPV and thus IRR will be. However, there will be a trade-off. So if we use debt financing, we will have to invest less equity. And if we have to invest less equity, we will need less cash flow in the future, which will equal our equity investment on a net present value basis. So often to optimize our IRR, it is going to be a trade-off between using a lot of gearing, so using a lot of debt financing to lower our equity investment, and to having early cash flows in early years. And one last comment about the IRR worth mentioning is that the IRR assumes that if we receive a cash flow as an equity investor in any year, we assume that we can invest this equity cash flow at our IRR rate up until the end of our operating lifetime. But this was it for the theory, so let's get going and actually model our IRR now. And we will only need one row here, so we will call this total equity cash flows. Like this. Let's pick up the unit, copy, paste. And our total equity cash flow will be simply the sum of our total equity investment up here. So this is the money we will have to invest, plus our total equity returns down here. Hit enter. Let's get everything over to the right, Control R. And now this is important, we won't have any row total here. And Microsoft Excel already has our internal rate of return calculation integrated. But what we'll need here is a small number. So this equals our small number. Hit enter. And you can see this is going to be a very small number. So basically 0.000 something 1. Let's hit alt HJ and let's make this a technical input. And we will need this very small number here, which will not have any impact on our actual return, that Microsoft Excel will be able to calculate our IRR. And then we will calculate our IRR here. So this is going to be our internal rate of return. This is going to be in percentage, hit enter. And then here we will have an INCHI calculation. And Microsoft Excel has different IRR functions. And what we will use here is our X IRR functions. So type in X. And then the first choice is already IRR, X IRR. And then first thing we will have to select is those values here up until the end. So mark all those cells here, comma, and then we will have to select our dates here. So go to row 5, mark all those cells up until the end as well. Hit F4 twice so that we can copy this IRR calculation for our unlevered IRR as well. And you can see why we need the small number here. So what we'll do is we will start our model here on the 31st of December, and we will have to have those two rows being exactly the same length. And we won't need any guess, so close parentheses, hit enter. Alt HJ, that is a percentage. Alt HJ, that is also an Inchy calculation, and it's also bold this number. And obviously something went wrong here. We won't have an IRR of 0%. And what happened is that this small number here has to be negative, as Excel can only calculate the IRR if this first figure here in the first period is negative. So let's put a minus in front of it, and then it should give us our real IRR. Hit enter. And it's good that you made this mistake once, then you will remember, okay, this number here has to be negative. And you can see we get a very good IRR, so we get an internal rate of return of this project of 15.64%. So this is a really good IRR, and most renewable energy projects are being sold at around 6 to 8 or 9% equity IRR, depending on your jurisdiction, and obviously also depending on the inputs that you assume. But from a project developer's perspective, this can be a realistic and achievable IRR. And in our next lesson, we will calculate our net present value. All right, guys, see you then.